Welcome back. We're ready for part 2 of our chapter 10 review, and as I said, we're going to get this maybe is the hardest, so make sure you do a lot of problems from this section. I know there was some on the review, on the practice quiz, so be ready for this, but really the key thing comes down to this: the ratio of sides. I'm not going to write it out when I'm going to say it. Ratio of sides is always equal to the scale factor, is always equal to the ratio of perimeters. This is kind of what's new. We talked about ratio of sides and scale factor already, but they're all the same. So for example, if you have a 3 by 5 rectangle, and you have a 6 by 10 rectangle, that's 10, then these are similar. And you can check it. Is the ratio of sides we see is 1 to 2, right? That's double. That's double. But what about the ratio of perimeters? Well, this perimeter would be 16, and this perimeter would be 32. Indeed, the ratio of perimeters is the same as the ratio of sides. That's just an example. That doesn't prove it, but we see it in that case. So how do these compare to the ratio of area? Remember? The ratio of area, are they equal? No, they're not equal, but you have to square the ratio of sides, square the scale factor, or square the ratio of perimeter to get to the ratio of areas. That's the big picture. That's the whole section right there. So they might ask you this. Here's an example. They might say the ratio of perimeters is 2 to 3, and they'll say, what's the ratio of areas? And you say, no big deal, it's 4 to 9. You squared the numerator and denominator, right? Or they might say something like ratio of sides is 4 to 5. Area of the larger one figure is, let's say, 45 meters squared. What's the area? This is a new problem, by the way. What's the area of the smaller? So you'd say, okay, well, I'd love to know the area of the smaller. I just got this value. This is no good. This is ratio of sides. I need ratio of areas to do anything. And I get 16 over 25, and I go, I can use that. Now the bigger was 45, so 45 goes in the denominator. So the unknown area goes up top. And I really made this difficult on myself since I don't have a calculator by me, but maybe I can do this in my head. We'll see. 16 times 45 is 8 times 90, but 720 equals 25A. How many quarters are in $7? 28. This is 28.8, I think. 28.8 is the area, and that is in, did I give any units? I did, meters squared. There we go. So that's a pretty common problem too. They could have had scale factor here. It'd be the same thing. They could have had ratio of perimeters. It would have been the same thing. But if you're looking for an unknown area, you need ratio of areas. This every year is something students get confused. So be careful. Just know that if you're looking for a ratio of area, or if you're looking for an area, you must use the ratio of areas. That's probably the toughest topic. The last two sections, I'll try to whip through here pretty quick, has to do with circles. So if you have a circle, and you want to know, let's do 10.6 first, which is arc length. So if you want to know how far is it along this edge from here to here, well, that reminds me of perimeter, right? The distance around, but it's not all the way around, it's just a part of the way around. And more specific than perimeter, it reminds me of circumference. Circumference is the fancy word for perimeter when we're talking about circles. So it's part of the circumference. Is it half? Not quite half. Is it a quarter? Looks to be more than a quarter. Well, how do we know? Well, you're going to have to be given a central angle, and let's say this one is 120 degrees, and let's say this is 4 inches. So the circumference of this circle, and you need to know this, is 2 pi r. 2 pi times 4. So that's 8 pi. If you want to travel around the entire circle, it'd be 8 pi inches. Is it inches? Inches squared? Inches cubed? Inches. It's a distance, right? Inches. Not squared or cubed. But I only want to travel this part of the way. Well, that's a fraction of the circumference. So you might remember when I talk arc length, I always describe it as fraction of circumference. Now, I guess it could be the entire circumference if your angle is 360. So what I mean, sorry, something on the screen here, it's bothering me. Okay, when I say fraction of circumference, let's do fraction of the circle times the circumference. That's what I mean, what we need to do. In other words, the central angle divided by 360, right? That's how much of the circle you're going around, times circumference, which we know from before is 2 pi r. So in this problem, we'll call make this red. Let's call that x. If you want to find x equals 120 over 360. That's the arc length. That's just such a bad x. I'm going to fix that. Times the circumference, which I could just write 8 pi because we just did that, but I'll just do this. This does reduce to 1/3. So you end up with 8 pi over 3 inches. Which, by the way, is a third of that, right? It's a third, because 120 is a third of 360, so it's a third of the circumference. And it won't always be that easy. Like if this number here was 119, well, that would just ruin our day, right? It would be a lot more annoying. It'd be a lot messier fraction, just 1 degree less. So I won't do that to you very much, but usually things that are multiples of at least 15 degrees, sticking with like 30s and 45s and 60s and things like that. That's arc length. And finally, sector area, almost the same thing. You have a circle. And I'll mix it up a little bit this time and make it a different angle. Let's do 45 degrees. So someone might be asking, what is the area of that sector, like a piece of pie or pizza? So this is called sector area, and it is simply the fraction of the circle area. Okay, so the formula is almost the same as the one we just did. Fraction of the circle times the area of the circle. In other words, central angle over, remember what it was? 360 times pi squared. Some of you are thinking probably, why is this formula so complicated? This is easy. It's just, and that's great. If you think of that, go with it. I try to show you how the formula matches your common sense. And if you got it, go with it. It isn't so bad. But if the angle isn't 45, if it's 40 or something, it's considerably harder to figure out what that fraction is. So I think using this can be really helpful. So in this problem, let's say this is 10 feet. This is a big circle here, 10 feet. The area of this sector would be 45 over 360 times pi 10 squared. By the way, that's 1/8. So this ends up being 100 pi over 8, and what do you know? We can reduce this again. 4 goes into both of these, so we end up with 25 pi over 2, or 12.5 pi feet. And these units are squared. It is an area, so it is a square unit. So it turns out that little wedge right there is 1/8 of the circle. And you might remember that 45 degrees is 1/8 of a circle. If you see a piece of pizza cut into 8 pieces, that central angle is 45 degrees, assuming they're all congruent, which they try to do with pizza. So that's basically what you have with this chapter. I hit the basics. Hope that helped make sense of things, and hope to see you at the office.